let's imagine a curve, right? Now, if we zoom in on this curve and we focus on this little tiny section underneath the curve and we wanted to find out the area, how would we do that? We'd use these things called integrals. And if we looked at a specific point, one point, and we wanted to find what is the rate of change at that point, we would use derivatives. All right, and these are your basics of calculus. Now, what is calculus? Now, in Latin, calculus means small pebbles, and this is because in Rome they used to use small pebbles to calculate certain things. All right, but calculus is the mathematics of all things that change. And in calculus, we use three main tools: our integrals, our derivatives, and our limits. All right, and it's all about the rate of change, right? So from mathematics, we know rate of change, gradient is equal to the change in y over the change in x. y2 minus y1, x2 minus x1. So we know if we looked at this graph and we had our 2 points, y2 would be f of x plus h, y1 would be f of x, those kind of things. You could find the rate of change on this graph. Okay, and so we know then that the rate of change would equal to that, all right? F of x plus h minus f of x, x plus h minus x, all right? But then we need to come to this thing called limits, all right? And you'll see why now. It all connects, right? And limits is telling us that we're approaching a certain point. So as x approaches 2 would be a number like 1.999999999, right? It's approaching 2. Okay, so the limit as x approaches 2 of f of x is f of 1.999999999, right? And so we could then say that that would then be 2, right? So the limit as x approaches f of x, as the limit as x approaches 2 of f of x is equal to 2, right? As we can see by this graph, okay? But then let's now say that if we looked at this old graph, remember we had this where we had our 2 points f of x plus h and f of x, okay? If we then said, all of a sudden, now h approaches 0, that means it would be 0.000000001 maybe, right? Because h is approaching 0 because of our limits. What would we then do? We would then say it would be the normal gradient, the normal rate of change formula, but now as h approaches 0. And this is the definition of your derivative. It is finding the rate of change at a specific point because h tends to 0, right? The difference between 2 points is now very small, so we're technically just finding the rate of change at 1 point x, right? Or f of x plus h, since h is so small. And then we have these things called the inverse, or they're called sometimes the inverse of derivatives, and these are known as your integrals. And integrals, as if you remember from the beginning of the video, we said would be used to calculate the area underneath the curve. All right, this is just the basics of calculus. We're going to go over integrals and derivatives and limits and questions on them all in further videos. This was just the basics, right? I really hope it helped. Have a great, healthy day. It's Curated.